Okay, example 4 involves an infinite domain. So when you have an infinite domain, in other words, there's infinity real numbers, right? Before I had to test a couple, right? Well, 5 goes to one thing, 4 goes to one thing, it's a function. Now I've got infinity things going to infinity things. I don't want to go through each one individually. That would take a little while. All right, so that would be a bad plan. So what you have to do in a situation like this is you have to convince yourself of two things. Number one, the relation thing. If I put something in, I'll get something out. That's all a relation test is. So you have to ask yourself, is there some number out there in the world of real numbers that if I do plus 2, it's not going to make an answer? Can anybody think of that number out there? That any number out there in the world, if you do plus 2, let's just pick some random numbers. Let's say 7. What's 7 plus 2? 9. Right, so you put 7 in, 9 comes out. So if 7 works, right? Is there any number out there, if we throw it in there, the real number, and we do plus 2, we won't get some answer? No. So it's a relation, right? If I put something in, I get something out. That's all the relation test is. The second question is, if I put something in, I'm going to get one answer for everything I put in. I put 7 in, I got 9 out. Did I get anything else? Okay. -5 plus 2 is -3. Nothing else, right? Can anybody think of a number out there that I can put in here that I do plus 2 and all of a sudden get 2 answers to it? No. All right, so that's a function. You have to pass the two tests. If I put something in, I get something out, relation. If I put something in, I get one thing out every single time, function. All right, and that's how it goes. Let me give you an example, one that's infinite that's not a function, just so you can get an idea of this. Let's say this is just integers. It doesn't matter what this infinite set. Okay. And let's say y equals 2 plus or minus the square root of x over 7. All right? So let me pick an integer for you just because I've got some preconceived notion on this. Let me pick 0. Okay? Well, first of all, if I put, let's put positive integers even so we can actually do it. Because it wouldn't be a relation otherwise, right? Pick a negative number, doesn't work then. Not a relation. Now it is a relation because positive integers, I can take the square root of any positive integer, right? Some of them aren't very friendly. Square root of 2, square root of 3 aren't very friendly. Square root of 4 is 2, that's friendly. But positive integers can be evaluated, right? So if I put something in, I get something out. All right? If I put 0 in, let's say non-negative, because I want 0 to be available. Z plus, comma 0. There we go. So 0 is included. Maybe I should just say whole numbers. Oh, that'd probably be easier. Whole numbers. I knew there was a way to do that. A good video here. Whole numbers. All right. So if I put 0 in, what's 2 plus 0?
2.
Over 7 makes 2 7ths. 2 minus 0? 2 7ths. So if I put 0 in, I get 2 7ths out, right? I put one number in, I get one number out. It's acting pretty good, right? It's being very functional for us, right? Suppose I put in 4. 2 plus 4, the square root of 4, so 2 plus 2, right? 2 plus 2 is 4. And 2 minus 2 is 0. So if I put 4 in, I'm going to get 4 7ths and 0 out. This is a no, and 4 goes to 2 numbers. So does 1, so does 2, so does 3, so does 5, so does 55, so does 8,944. If it's not a function, you're probably going to find a bunch of things that go in this. Just give me one, a counterexample. If you want to show something's not a function, this one thing goes to more than one thing. This is not a relation. Those are the two reasons it won't be a function.